So the test is going to be tomorrow and the next day. The first one's on graphing. The second one is, and so therefore you need a graphing calculator. The second one is on algebraic manipulation, which basically means, doing a lot of quadratic formula kind of stuff where you can't use a calculator. Otherwise, you'd use the calculator because that's a lot easier. All right, so the calculator part I think is a little easier, and we're doing it first. Yes. Yes, you have a worksheet for review today. Yes. Are you leaving early or something? Okay. All right, so some crucial skills. Here's one. When you take and square both sides of this, no, not square, square root both sides of this to get rid of that squared thing, how many of you, be honest, would have remembered to make it absolute value of x minus 3 is less than 9? Okay, so that's one of those little things you need to learn now. Whenever you take the square root of both sides, you need to put in the absolute value on your answer. And then the absolute value, I hope you knew that you'd split that into two parts. X minus 3 equals 9. Or, sorry, is less than 9. X minus 3 is greater than or equal to negative 9. And then we got our 2. I add 3 to both sides. X is less than or equal to 12. And add 3 to both sides. X is greater than or equal to negative 6. So now, here's the part where you got to put it on a number line. Why? Why can't I just say the answers are negative 6 and 12? Because it's a less than or equal to. Whenever it's a inequality, where it's not just equals, you got to do this part. Negative 6, 12. And then you test. I'd like you to finish this off. Test all three regions. Figure out where it actually works, and like leave your answer as something like this. That kind of thing. Okay, figure out where it works. I'm going to hit pause while you finish that. Okay, I can't believe that microphone has been off for the last couple problems, so we still have quite a bit of the lesson left, so hopefully kids didn't give up on it. Maybe I'll title it, it says something like microphone's off for a few minutes, just fast forward. Okay, anyway. There's certain days when everything just doesn't work well. Last hour I recorded the lesson, and then it pulled up after, like, it was partway through processing it. It said, it gave me two choices. Do you want to save this as a file other than an AVI? Okay, never asked me this one before, and so I said no, and then it was like done. So like, okay, then I'm not saving it at all. Like, what? So anyway, it didn't save it last hour, so I'm re-recording it now. Anyway, if you were doing this when you're graphing it, I'm hoping you just graph this side and graph that side and see where they cross. Could you pull it over, the 9 over to the other side first? Yep, but that's more work because you don't have to actually, and maybe you're going to make a mistake in doing that and by accident put a positive 9 or something when it's really supposed to be negative 9. Maybe you'll make a mistake, so don't do things that increase the chances of mistakes. And you see where they cross. Now you need to know two things. You need to know if it's graphed like this, it's going to be one of these where it'll touch here, and you needed to be able to follow the thing under second, calculate zeros. So you'll be able to move the little spider to the left of it, to the right of it, and then right on top of it and hit enter. The other way you'll have to know is if it's like this kind, where two things are crossing, you'll have to do intersect, and it'll say first curve, so you get on the red line, for instance, and hit enter. Second curve, get on the blue line, and then it says guess, you get right on top of where they intersect, and you hit enter one last time, and it tells you the answer. So anyway, it's under second, calculate. It's huge that you know both ways. If you don't, then come up and ask me during like work time today, and I'll show you how to do either of the two kinds. All right, finish it off. What did you get for this? It's like 1 point something, I think. 1.6? About 1.6. Okay, and if I actually just think about the answer and see if it seems reasonable, 1.6 cubed, it's going to be some smallish number, and then I times that by 1. That's like 6 plus about 3 makes about, that seems reasonable. Okay. So you double check your answers, make sure they seem like they work. All right. Moving on. This one. Whoever says the answer first correctly will earn my undying admiration. What is it? See? He's done already. No solutions. Do you see it now that he said that? Because whenever you have an absolute value equaling a negative, you can't have that. It doesn't work. You could never. You could go through the process, split it into two things, get answers, and they would be what kind of answers? Extraneous, because you'd try them and they wouldn't actually work. And then you'd be all paranoid that you were doing it wrong, and then, well, am I doing it wrong, or is it they're extraneous? Well, right off the bat, you see that an absolute value is equaling a negative. No solution. All right, moving on. This one, what would you do first? Plus 9. Then I have the 9 goes over here and makes this a 30. And now what do? Multiply by... No. What do? Split it. Don't get fooled by wanting to get rid of this until later. It's an absolute value. It's got to get split. So once it equals, this is gone, and it says equals 30, you split it into two parts. All right, just a reminder about that. Next thing, two numbers are related in this way. This is a word problem. These are the hardest for kids. I'd say the vast majority of kids can handle the other kind. They might make a little dumb mistake, but they know what to do. These get far more confused people. So follow me on this and see how to do this. The first thing is, if you can draw a picture, if it's like a rectangle or something, go ahead and do that. But in this case, we can't draw a picture, so we do something like that. An alternative is to make like a little chart. If you can't make a picture, maybe you can make a chart. And I got two numbers, right? I got my first number and my other number. And obviously, if they're not the same number, one's bigger than the other one, right? So I'm going to call this the smaller, or small number, and this the big number. And then I got to use variables for these because I don't know what they are. So what's a good number for the small number? X. And then the bigger number, that I have to think about. One is 10 less than the other. Well, then the bigger would be x times 10. Now, some kid is going to say, well, couldn't I say that the bigger one is x and the smaller one is x minus 10? Sure. You're not minus 10. Well, 10 less. I'm sorry. I thought it was 10 times. My bad. I screwed that up. I'll start over again. I have x for my small number, and it says 10 less than the other. So the bigger one then would have to be x plus 10. Sorry about that. Now, some kids are going to say, can I make the bigger number x and the smaller number x minus 10? Sure. Either way works. What do you think's a little easier? The top one or the bottom one? Top one, because why? No negatives. Trip you up. All right, so let's try that top one. We'll say that the small number is x and the big number is x plus 10. Then, the sum of the numbers increased by the product of the numbers is 415. As soon as you see something like is or results in or whatever, you know you just read a big equation. And so you should be able to say, okay, I got to write a big equation equals 415. Be writing it backwards there. So I'm going to write this equation out and see if you can follow this. The sum of the numbers, that means adding them. I can't make up numbers, I use these. So x plus 10, that's the sum of the numbers. Increased by, sounds like add to me, the product of the numbers, that's x times x plus 10, is equals 415. So now, do you see a great big equation that could be solved? Yes. And if you wanted to just graph it right off this screen, you could. You could try like simplifying it a little bit and adding these two x's and call it 2x plus 10 plus x times x plus 10 equals 415. Absolutely, you could graph all that. All right. Now, this part, remember, in the problem, it said the sum of the numbers. This is the sum of the two numbers. This is the first number. That's the second number. This is the product of the two numbers. Product means multiply. All right. So, to finish this, I'm going to just graph what I see. Graph this side right here. And graph this. Y equals on both of those. And then I'll see where they cross. Why don't you try that? One of them is a curvy kind of a line and has a line going across at 415. So if your window is at standard zoom, you can't possibly see up to 415, right? All right. I'm going to put some stuff together before I put mine in the calculator. I'm going to say the x and the x makes 2x. And the x times the x is x squared, and that's 10x. So plus 10 plus x squared plus 10x. And I put that all together, and I have x squared plus 12x plus 10 equals 415. I'm going to graph those two. X squared plus 12x plus 10 equals 415. So I go to quit out of this mode, go to y equals, and I want x squared okay. I'll have to type in x squared plus 12x plus 10 and I go down to the next line, and I type in 415, and I say graph it. And again, I can tell ahead of time I'm not going to be able to see where 415 is. One thing that's kind of cool is different zooms. Like zoom 6 is I'm not going to be able to see up to 415 with that. But zoom 6 is like the standard zoom. But zoom 0 sometimes it works miracles. Ah, I can see both lines now at least. But I can't see where they touch. It must be way over to the right. Okay. How about if I try a different zoom? Zoom, maybe zoom. Okay. Ooh, look at that. They crossed. Zoom 5 was looks like it's going to work for me. Now, if I wanted to move this whole graph up a little bit, I'm just going to touch my window and see where I am. I want to be able to see higher. Is that an X thing or a Y thing? Y. My Y max right now is 415. I want to see higher than that, so I'm going to go up to like 450. And I hit graph. I just want you to be able to play with this and like be able to tell what's going to happen. All right, now I can see where they cross. Now I'm going to try it. I'm going to go a second, calculate the intersection. That's number 5. And first curve, I get out of the first line. I'm already on one of the lines, so I'm going to hit enter. Second curve, it automatically moved me to the other line. Awesome. Guess, I kind of arrow over so I'm right near on top of it. Close enough. I hit enter. And how come it isn't giving me an answer? That's weird. I think my calculator just froze. Can somebody tell me what you got? 15? Okay. All right. Sorry about the technical issues there. So it's 15. If X is 15, then I go back and I stick that into here, and that's the small number, right? So it's 15. What's the other one? X plus 10, which is 25. So 15 and 25 must be my two answers. Notice how I can't just say, oh, the answer's 15. I got to go back and look and see what does that mean? I got to see, oh, that was the smaller of the numbers. Maybe in the directions, I should make sure now that 15 and 25 actually work. And again, if this was my test and my A was going to ride on this, I'd probably double check that. And I'd see if these numbers actually work in there. I'd take the sum of them, I'd take the product of them, I'd add it together, and I'd see if it came up with 415, and I think it does. All right. That showed a whole bunch of different things. Here's another word problem. Draw a picture. Write a formula that works for it. Take the stuff from the picture, put it in the formula. I'll pause while you work on this one. All right, I'm hoping that you've got a rectangle on your paper. And then for your sides of this thing, you could go with multiple different ways of doing this. I would go with the smaller side as X, and then the bigger side is 4 times that, 4X. Does this make sense so far? Is that an okay way to do it? Okay, you could have gone with, if you wanted to, you could have said this was X, and that this other side was 1/4 of X. This is harder. You have fractions, and it's just harder to think. Take the smaller one, make it the variable, and then make it bigger to get the other one. Okay, and now a formula I know about rectangles. Do you know this one? Area is length times width. Always start with the general form of the formula, and then from there we can stick in what we know. But here's the problem. Area of half of the rectangle is 128. I can't put 128 right here, can I? But I could put in 256. Because now that's my whole area. That's the easiest way to fix that. Otherwise, you could have messed with the formula and stuff, but it's way easier to do this, I think. Okay, next, the length. The length is 4x, and the width is x. So length is 4x, width is x. Okay, so the 4x times x is 4x squared 256. Divide by 4 on both sides. 64 is x squared. At this point, when I take the square root of both sides, do I get an absolute value of x? You bet I do. But that'll mean positive and negative 8. But in this case, only one of them can actually work in the real world. The positive 8. So therefore, the side is 8. And this other side is 8 times 4 is 32. So it's 8 by 32. And if you wrote that, I might have to mark it wrong, because what did I ask for? The length of the shorter side. Always go back to the original question. I have to figure out, did I actually answer his question? What is the length of the shorter side? 8. 8 is the length of the shorter side. Okay? All right, moving on. How can you do this kind? I see somebody grabbing their calculator. So, that's right. Grab your calculator. Use linear regression. Type in these numbers. See if you remember how to do lin-reg. You'll get an equation. It'll be like y equals 24x plus 13.1 or whatever it is. Figure that out. Then use that to figure out this. Let's say I told you that the person was 200 centimeters tall. One more piece of data here. How long would their pinky be was the question. Okay, if you're having trouble entering this, please come up here and ask me. Or raise your hand. Okay, so I'm under Stat and Edit, and then you're seeing my list here. And if I want to take this data now and get an equation for it, I go back to Stat. I arrow over to Calculate. I do the fourth one, lin-reg. And I hit Enter. And there's my equation. Now, if you put yours in the opposite order, I put in the top row as the x's. If you put in the top row as the y's, your equation would definitely look different than mine. But the other advice I have for you on this is don't cut off those decimals at all. I'd put down every one that I could write because it makes it more accurate. So, see if we can do this. 24.571428. 571428. And that's x. And then the other part, the b part, is 29.9142 plus 29. There we go. All right, so now I got this big old equation. How do I use it? When I gave you 200, think now. The way I did it, I made these x's and these y's. They basically told me y is 200. You'd put the 200 here. If you did the equation backwards, then you would put yours into x. Mine's going to go into y. So how do I solve this big red equation? I just have to subtract 29.9142 from both sides and divide by that awful 24.571428, and I would get my answer. And I think you come out that his pinky is like 6.8 or 6.9 or something like that. All right. Raise your hand if you got an answer like that. Okay, good. If the end part is what you messed up, then it's probably because you just assumed and slapped this number in for the x. You can't assume they're going to give you the x. They might give you a y. You got to know where to put it. If they give you a number, you got to figure out, did you put those kind of numbers in for x's or y's? And the way I did it, I had used that kind of number was the y's, so that's why I had to put it here. Okay, any other questions or comments about this? Yes? Yeah, you can. Yes, when you put it in, by default, the first one you put in, L1, those are always the X numbers. And L2 are always the Y numbers. I put in these right here as all my L1s. Okay? Now you could have, some of you are probably picturing, taking this whole chart and like turning it sideways and then these would become the Y's. You can do that. You can do that. It'd be fine if you made these the X's and these the Y's. But then when they give you this number, you'd put it in as an X. And you'd have a different equation, and that's all okay. You can have a different equation for it if you do it backwards. Yes, ma'am.
Well, I had like 6 numbers before, so then when I was entering in those 4, and I put like zeros as the other 2, and I guess that messed up my data.
Ah, yes.
So,
You
but like, how do I get rid of the zeros?
Good question. So let's say that you have numbers, data already in your lists. How do you get those cleared out? You go under Stat, Edit, and if I wanted to get rid of, let's say I had a number in here I didn't want, I just hit the DEL key, a delete key. And you're right, having an extra zero in your list would definitely throw off your numbers because it thinks that somebody's pinky length was 0, and I suppose that's possible if they've been through a wood chipper or something. All right. Okay. This is similar to one we did before, except it's a lot easier. I want to do this one where you make one's the larger, one's the smaller number, and you make the equation and you figure this out all by yourself. Okay, here we go. So the smaller and the larger, you can pick this to be x and then this to be something else, or you can pick the smaller one to be x and then the larger must be something else. I'm going to start with, let's say I assume the larger is x. They're consecutive even numbers. Then if the larger one is x, the smaller one must be a little smaller because remember, these are even numbers like 2, 4, 6, 8, 10, 12. So can you see it would be just x minus 2? Another way to think of it is, if I make this the smaller one x, then the larger one would have to be x plus 2. Those are two even numbers. You're right, actually. Where'd you learn that? That's good. I did that? That's so weird. That's right, I did it on the video, didn't I? Okay, you're right that that's a good way to do it, to use 2x and 2x plus 2, but there is a, this is just easier because then when you multiply them together, it's still going to work. Here's the thing that I figured out after last year, after recording that video, is that way that I did is really good and it always works, but this way pretty much always works too, and it's simpler. The only thing that will happen that could throw you off is this answer could come out to be an odd number. And the way I did it with the 2x thing, it'll always be guaranteed to be an even number. But I just say to you this, if I get two answers and one of them is odd, am I not going to throw it out? It says even numbers. So unless I'm dumb enough to put down my answer is like 17 and 19, well, those aren't even numbers, so I throw it out. So this way works great as long as you're careful that at the end that it's really an even number when you're done. All right. I was like, man, this kid's really smart. Where did he hear that? Okay. Product of two consecutive even numbers is 168. So I go x times x plus 2 equals 168. And then I say x squared plus 2x equals 168. Then I get the 168 over to the other side, or I could even, if I had a calculator here, I could graph this side, see where they touch. Otherwise, x squared plus 2x minus 168 equals 0. Factor x, and I gave a hint that 14 was a factor. 14, and I think it's 12. And is this plus 14? I guess I can figure this out. It has to come out to positive 2x, so yeah, that's a plus and that's a minus. And then the final answer is x equals negative 14 and x equals 12. But I can tell you this, that's not my two numbers. It's not 12 and negative 14. That would be wrong. I got to take these and see if either of them are extraneous. You know, I was saying, like, what if one of them came out to be 17 or something? Well, this one works. And this one, I think, also works, but we'll test that in a second. It's not my two answers, though. I should say 12 is the x. If this is 12, then what would my larger number be? 14. 12 plus 2. So my answers would be 14 and 12 are two consecutive even numbers that multiply to make 168. But so, is negative 14, and what would go with it as a consecutive even number? Negative 12. And if you multiply them together, the whole point is that the product of them should equal 168. Doesn't negative 14 and negative 12 multiply to 168? Yes, it does. So this is right, and this is right. And would you have to have both? No, because the problem didn't say that. It said, what are the numbers? It didn't say, what are all the possible answers? If it did, you'd have to give all of those. But since it only asked for what are numbers that would work, these would work. Most people give these because they're not sure what to do with the negative even numbers. It's kind of weird. Yes? There are little hints given on the tests. Now, yeah, I know. This one I wanted you to do by yourself. The other one is more like what you'd probably have. Remember this one? Where you had to write this big honking equation out? It's going to be more like that. Okay, so you can't just guess by, like you said, the hint made it like, okay, 14, well, 14 times 12, oh, two even numbers, there they are. You're right. But you won't be able to just guess and check on the test. Pretty much guaranteed. Like this one, you would have never been able to figure out that it was 25 and 15 just by the clues. Okay, so there's only one more kind of question, and I know you're going to see this kind of question again and again. So we need to do one today, and then you'll see them again and again. You know when you take a cardboard box, and it's three-dimensional, right? Doesn't it start out as one piece of cardboard, flat? It's just a big rectangular, probably, piece of cardboard like this. And to make a box out of it, they basically cut notches out of it, and then they fold it all up. Well, this one, it says that they cut corners out of it. They don't say how big the corners are that they cut out, but they cut corners out like this, and you fold up the sides to make your box. So like little dotted lines are where you'd put folds. Everybody draw one of those quick. Once you've got this, you're halfway done with the problem because you can start to see where to put the numbers they gave you. All right, it says this 15 by 12. I'm going to say this way is 15 and this way is 12. But when I actually fold my box up, do you see how it gets shorter than 15? Because when this side gets turned up, and this side gets flipped up, then it's not 15 anymore. It's 15 minus something. Well, I don't know how long this is, so what am I going to label it with? X, exactly. And this also is X. And so, what do I do? How long is it? How wide and how high is my box? I need that because I need a volume. And the volume formula is length times width times height. So what's my length? My length isn't 15, it's 15. 15 minus 2x, very good. Because I got to subtract off this x and subtract off this x, my total will be 15 minus 2x. My width isn't 12, it's 12 minus 2x. I also have to subtract an x this way and an x this way. Yep, it says it's a square on the corner, which means that the sides have to be the same. This x is the same as the other x. They're all x's. All right, so I got my length, I got my width, now the height. The only other dimension is like the really short dimension, which is what? X. Now volume equals length times width times height. And actually, we didn't know the volume. The volume is supposed to be 125, so we'll put that at the end. So it's length times width times height is 125. Length, 15 minus 2x. Width, 12 minus 2x. Height, x. And it says at most 125. That means I can't be bigger than 125, but I could be less than 125. Okay? This is about as hard as they would ever get. But you will have to know how to do this kind of problem. If it's not now, it'll be later. Okay? All right, now how do I solve it? For me, and I had a graphing calculator, you don't have to do this right now. I'll save us some time, and just trust that if you graph this side and you graph this side and you see where they cross, you're going to get your answers. And then since this is a less than or equal to sign, you'd have to graph and say, all right, say I have two answers here. I have to test in here, see if it works, test in here, see if it works, test in there, see if it works. That's what makes this a tough class, because you got to put together all these little things you've learned. You learned how to write equations like this kind of thing in algebra. You learned probably how to draw simple pictures like this back in 6th grade, I'm going to guess. You're learning now how to solve big equations like this guy with graphing. That's probably the new skill. And then the inequality part, you know, less than or equal to, and having to do the number line, that's also fairly new stuff. And your final answer would be like, you could cut a corner out that's between a 1/2 inch and 3/4 inch, and it would work. That kind of thing. Oh, snooze that. Okay. So, I think that's everything that you need to know for now. And I want you to especially focus at the end of the hour here on that. The worksheet I gave you is your homework. I would check it on Schoology, and I would make sure that you know how to use your calculator really well. If you can't do a linear regression on it, if you can't find intersections, if you can't find the zeros, any of that like little how do you do this stuff, ask me now. I can't help you during the quiz or the test. And let's come back tomorrow and kick some butt on that test. Find out who my A students are.